Hi, everyone, and welcome to another stream by Offensive Security. My name is Siddicky, and I'm a student mentor at OffSec. Today, we'll be covering the machine Alice from the PWK Learning Path. This is a Windows machine and is considered to be one of the low hanging fruit targets. Let's wait a couple of minutes for people to arrive. For those watching this on YouTube, kindly start from the 10-minute mark. So, those joining us, we're just waiting for a couple of minutes for everyone to come in. And if you guys have any questions, in the meanwhile, you can feel free to send them in the chat and we'll just start shortly. Hi, good morning. So glad you guys could join in. So I see people are still trickling in. So, okay, so I'll just go over the agenda again. Today we'll be covering Alice from the PWK Learning Path, and it's a Windows machine. And yeah, guys, Siren is also here in the chat, and she'll be monitoring me today and helping out with the chat. So yeah, you guys, if you guys have any questions and you want to reach out to her, so just leave it in the chat. And yes, it will be saved to YouTube afterwards. So the stream is probably going to be around 45 to 50 minutes, but we'll see how it goes. But yeah, the machine isn't really it doesn't really have that many steps. However, I'm hoping to showing you guys some nice techniques that might help you during your time in the labs. Also, just a small announcement. So during my time interacting with the students, I do see that most of the students would like to use the non-Metasploit version or exploits to get the machine. So we won't be using any Metasploit for this machine. So that's a plus. If you guys wanted to see that, you've come to the right place. Also, let me just take a poll. So, how many of you guys here have done this machine already in your time in the labs? Yeah, so you don't have to worry about that today. Hopefully, the shells we try to spawn would be coming back, and maybe you can try that again on your end and see what was up. Also, I do believe most of the students do encounter this machine because if you look at the IP addresses, this is the first one that is on top of the list. So I think everyone has, at some point, tried their hand on this machine. So it's in the public network. No, so this isn't in the proving grounds. This is part of the PWK learning path. So when you enroll for your OSCP, it's one of the machines that you encounter in the lab. So unfortunately, you have to enroll in the PWK to be able to, get to this machine. Yeah, it's more of a demonstration. So you guys are free to take notes right now. But yeah, uh, it'll be best just to, enjoy the stream and then try your hand later at it. Also, we'll just be starting in 30 seconds. So I hope everyone's ready. We're going to have a good time. And anyone who's struggled in the past can finally get some redemption. So, yeah, just to recap before I start, my name is Siddicky and I'm a student mentor at OffSec. And today, like I mentioned, we'll be covering Alice from the PWK Learning Path. This is a Windows machine and is considered to be one of the low hanging fruit targets. So, without giving anything else away, let's jump right in. So I wanted to showcase a few quality of life optimizations I've made, which really helps me along the way while doing the machines. So I have two TMUX sessions, as you can see. So this allows me to run my VPN in one session, and I'm quickly able to monitor if anything goes wrong. Also, if you notice in my bottom right corner, I have the IP variable, especially my tunnel IP, displayed down below. So this really helps me out because, and every time you reconnect using the VPN, you get assigned a new IP address. And you don't want to be trying exploits and then in the end find out, oh, I was using the wrong IP. So this really helps me out. So let's come back to my main terminal. Now, I reset the machine 6 minutes ago, so it's really that looks good. So we'll be doing two things before we actually start. The first thing I like to do, let's open a few more windows. So I think six is enough. And let's also set the IP variable so that we don't have to keep on typing the address. You can also see that I have my tmux configured in a way that it sends the same command to all of my windows. So that really helps me. I don't have, it'll set the variable for all the sessions. The second thing I want to do is also set a variable for my working directory. So I'm just going to copy that and set it. So that looks great. We have our workspace all set up. So now we can actually run some scans and start exploiting the machine. So because Nmap can take a bit of while to run, I already did the initial scans, as you'll see right here. So now we can actually go to my notes. So this is just a template, a summary template that I like to use for all of the machines I solve. But we'll come back to this later, and we'll be filling this up as we go along. But the main part we want to look at is this. So I'm going to select my all port scan. And right off the bat, we can see we have 135 open, 139, 445, and 1025. So this shows that it's probably, not probably, but by default, it's RPC on the client. And then we also have SMB. But so this will give us an idea that fine, we're dealing with a Windows machine. But now let's also go to our services scan. So one thing I like to do here, you'll notice, is that I like to specify the ports that I just found and then run specific scans for default scripts and versions on these ports. This really optimizes it and helps return the scans much quicker, as we won't be scanning for the versions and the default scripts for all of the ports. So now if we look at it, again, we had 135, which was RPC, 139, SMB, 445 again, and 1025. But the one thing that does jump out is this. So it's the target machine is actually running Windows XP. Now, this is actually going to really change the approach we take with the machine. Because normally, if I see a port 80 HTTP server open, that's where I like to usually start. And then, go from there. However, because this is a really old operating system, so I think it came out around 2001, and it has many reported vulnerabilities. So I think a good place to start would be by checking for exploits for Windows XP for the services running. And we get a bit more information. So the host name is Alice, and you can see that the protocol negotiation failed for SMB2. So this is most likely because the machine is running SMB version 1. So we'll just make note of it in case we try to connect and it fails. One of the reasons might be that it's not defaulting to SMB version 1. But other than that, let's get a bit more information, because our approach will be to look for vulnerabilities specifically for Windows XP. So I'd like to get a bit more information on maybe the version number or some other stuff. So what I like to do, I'm just going to run enum for Linux. This is a great tool I like to use against Windows targets, as it gives us much more information. So I'll be running enum for Linux ng, and the syntax is this. And one thing I want to note, that normally when we want to save most of our scans outputs so that we can easily refer to them later. Now, one way to do that is to redirect it to a text file. However, if the tool we're using already has a built-in functionality to output the data to the scans to a file, we should obviously use that. So for enum for Linux, again, we have it follows a similar syntax to nmat. So we'll just save the output to enum directory and call it enum for Linux. Now, one thing before I run the scan, I just wanted to showcase the importance of updating your tools, because normally the tools that we install using apt, they'll get updated. However, we need to remember that tools like scripts like linps or even enum for Linux, we got them from GitHub. So they won't get updated unless you do so manually. So let's just check if our tool is updated. And I'm just going to use Fuzzy Finder to quickly look for my where my enum for Linux is. So you'll see that it registered as a GitHub repo, which is great. So all I have to do is do a git pull. Now, for me, it's up to date, but I would encourage you guys also to do this. And for those who really want to get into it, you should definitely check out what the newer versions have and what are the new features for the updated tools. But yeah, that's enough for now. So I'm just going to run this scan. And while the scan runs, let's revisit my notes. So as you'll see that we do have a bit more information. So let's just fill this out. We know it's a Windows XP, and the host name we did get, it was Alice. Uh, DNS, we're not sure at the moment. We could check for ICMP. This is a good way to test if it will respond, and also a good way to check your VPN connection. And because you can do a 10 pings or 50 to see if there's any packet loss, but that's fine. Other than that, this is a pretty bare bones structure. But yeah, but one thing that I did want to highlight is that the important thing to note is that although I have my notes open in VS Code on my VM for this demonstration, however, I would highly recommend that you have your notes on your host machine. This is primarily because you shouldn't have anything important on your VM and that it should always be treated as dispensable. Also, I would recommend using applications that support storing pictures like Obsidian, Notion, OneNote, or even Cherry Tree. I personally use Obsidian because I don't like to having my notes on the cloud. My notes are one of the most important things to me as a pen tester. So yeah, so we see enum for Linux completed, and we have two files. We have YAML version and JSON. You can choose any one you like, depends on your preferences. But yeah, so we can see we got a bit more information. So it's part of Think and the domain and work group name, but it's not really going to help us too much. But we do get more information that we were looking, and we can quickly just add this to our notes. We can also, because we have everything saved to output files, we can just revisit and do that later. But this is the most important thing that I was looking for. So it's Windows version 5.1. Now, because Windows XP had a long lifespan from 2001 to 2008, so if we can narrow down which service packet was running, that would be great. So 5.1, unfortunately, doesn't really help us that much because all the service packs from 1 to 3 had the initial 5.3, and then they had other text, other numbers that indicated which service pack it was running. But again, we got a bit more information. So we'll just add that. And also we'll see that although SMB was open, but the three shares that were available are the default ones. So nothing really juicy that we could obviously try to access them and see if there's something there, but most likely we're not going to be able to even access them. And they're default shares. So there's nothing really that we can poke around with, but I can try connecting to see if we can connect to them. So let's come back here. Now, I do want to mention that for Linux is kind of like a heavy scan, so you might get locked out for some services, but we'll just see. So let's see if we can still access it. So I'm just going to run SMB map and see if we can get anything. Okay, so that's promising. Okay, great. So like we thought, we don't have access. Another important thing I wanted to showcase is other ways you can actually fingerprint Windows operating systems. So one way is to run enum for Linux, but you can also use SMB map for this. So if we come here and we're going to do the same command, however, we're going to use the flag V. And you'll see that we were able to get more information about same information that we got from our enum for Linux scan, but this is a great way to do it too. There's another alternative to this is using crackmap exec. So I just want to showcase a couple of tools, a couple of ways you can fingerprint Windows, which I feel is important in case sometimes one tool doesn't work or there's some issue. So yeah, so now we had three ways to enumerate Windows. So I think we've done enough enumeration now. We can start looking for exploits. So now I'm just going to come back here and let's go to our trusty exploit DB to start looking for exploits. What we can do, we'll search. So we know we're looking for Windows, and type would be remote because obviously we're not on the machine. We're trying to exploit it remotely. So yeah. And I'll actually start with RPC because RPC is in the remote procedure call for Windows is actually a really important service which interacts with all of the others. So it interacts with 139, it's on 135 and 1025. So I think that is a good place to start. So I'm just going to write RPC and search. Let's increase the results and we'll sort it in an ascending order so that we can see from the start. So obviously Windows XP came out in 2001, but we started looking at exploits from 2003 because we should give Microsoft some credit, right? So I think this one looks really promising because it follows the naming convention for MS03026 and also it specifies that it's for Windows XP. Especially for Windows, it's really important that the exploits we're using are specifically made for the version we want to exploit. So I'm just going to open this one and let's also get a backup. Okay, let me just go back. Apparently that did not open in the second tab. That's fine. No worries. Okay, so let's also get a second exploit just as a backup in case that doesn't run. So we can see all of these are simply variations of the same one. So we can ignore these. And so here's the new one, MS04 And this also targets RPC and is also a buffer overflow, but it uses the LSAS DLL. So I think we can check this one out too. So I think we have two of them. So let's just see what we're dealing with. So it's in C, which is fine. We can just compile it on our Linux machine and we'll be able to run it and also look at all these options it gives. So I think this one's promising. And we'll look at it more in VS Code where there's more highlighting and stuff. So let's also look at the second one. So this one is actually, it's also in C. However, it's made to be run on Windows machine and specifically for Windows 32-bit. So that's not actually a problem. We can use Wine to run this exploit on our machine. The only issue I see with this exploit is that it doesn't specify it that this is for Windows XP. So in order to do that, we can simply grab the CVE and let's search using the CVE for any the exploits for the version we're looking for. So this is much better. So now we can see we have one specifically made for the Windows version we want, XP, and there's also a Metasploit module for it. So that's always a good indicator that we're on the right path. But yeah, we won't be using any Metasploit for this demonstration. So let's also check this one out. And yeah, this one will have a bit of functionality because it allows us to change the versions. So that's great. And it's been tested on so many versions. So that's promising. So I think we have the ones we need. Let's just copy these to our notes. And I'm just going to move this to my second window. And now let me just grab the names. So we'll be using two exploits. So exploit 1 and exploit 2. So let's grab the first one. And because we're actually using exploit DB, we can just use, instead of specifying the CVE, we can just specify the ID. And you can even, for your exam, if you just specify this for your report, this works fine too, because you've specified the EBD ID. And let's just grab the link. This looks great. So let's grab the other one. Similar edit right here. And it's 295. And let's grab the link. So that's great. We've documented what we'll be using, and let's see if they actually work. So now I'm going to move this to my first terminal, and let me create a new directory and cd into it. So I'm going to create a new directory called exploits. And I'm gonna grab the exploits from here. So this one is going to be named as MS3426. And we specify that it's C code. Great, that looks like we got that one. Let's grab the other one. And this one is MS04. Okay, great. We have both of them. I'm just going to move this back to my second window so that we have better real estate to work with. So now we have two exploits. We can compile them. So the first one, 026, would be easy. We're just going to use GCC. We specify the file name and the output, and we'll just use it like so. Now, one thing is that it will show warnings, but the only warning you need to worry about is if it says it did not compile. We'll try to run it and see if it compiled properly, but yeah. So the second one actually, because it's supposed to be made for Windows, uh, it'll give us a Windows executable. And the tool we'll be using to compile that would be Ming32. However, the syntax, the tool is a bit weird. So it starts with 86. Yeah. And then it gives us a couple of options. Because we'll be compiling C code, we'll just use the GCC. That looks great. Similar syntax argument, yeah. And we'll just specify. So one thing to note is that it will give a Windows executable. However, if you don't even specify the extension, it'll automatically revert to exe. Now, one thing that you need to remember is that it's supposed to be compiled for Windows 32-bit, right? So for that, we can just use what was given in right here. So if we come here for the exploits and look at this exploit, here's the library it tells us it needs. So we'll just pick this up, come back here, and the arguments are -L and specify the library like that, and it should compile. Okay, so apparently there is no file. Oh, I gave the wrong argument. That's fine. Okay, now let's see if they compile. So let's try to run the first one. Okay, that's good. Looks like that worked. What about the second one? Amazing. Both of them compiled and successfully. So now let me just grab these names and get a bit more organized. So I'm going to name this window as the first exploit. And let me grab the name of the second one. So this just help us be organized, right? So I think we can start to run the first one and see if it works. So it needs a target ID and a target IP because we're most likely 5.1. So I think going with Windows Service Pack 1 would be fine. So let's just try that. And it needs a target ID. So we went with 6 and the target IP. Let me clear my screen before I run it. So let's see. And there we go. We got a shell. But let's also try the other one. Let's just quickly see if this shell is stable. Okay, that's great. So while we're at it, let's also run the other exploit, right? We just need to cd into exploits. And let's run this. Let's see what it needs first. So I think this also gives us the option to have a reverse shell. Now, with the first one, we used a bind shell. Let's also look at the code to see if it was a bind shell. So the first one was this, and let's see what it does. Normal stuff. Ah, so here it is. It opens a bind shell on port 444. And I guess we could have, so there's not much leeway in this exploit as it won't let us, make changes. especially with buffer overflows. There's a limit, there's a space allocation, so you can't really just put in your own shell and try to you know hope that it works. So we can't really mess around with this one. But let's look at the other one. So we can see it actually, this one has more variations. So it allows us to run a reverse shell and a bind shell, and this one is more flexible. So let's try a reverse shell with this one, and that will also help us see if there's any firewall open on the machine. So let's come back here, and what we'll do. So the target is going to be 0. From here, we want to run it for Windows XP Professional. The IP variable, bind port. I think if we give our our own IP address, this is automatically going to be turned into a reverse shell IP. So I'm just going to try 443, and I'm going to give it my own IP address. Let's also start a reverse shell. Uh, what I like to use is grab LVNP. This allows me to quickly use left, right, everything. But because I use this so often, I already have not an alias. This is actually a function I've made for ZSH. So it quickly allow me to make any reverse shells I want, and also lets me echo some text just to keep things, classy. So yeah, I'm gonna start a reverse shell right here, and let's see if this works. Looks like it's working and it's attacking. Let's see if we got a shell. So we need to make sure that because we just ran 2 buffer overflows, so there is a chance that something might not work. But that's fine. Although it did say it ran, let's see if this was an issue with what we gave. So let's try the bind for this one. Let's see if the bind port works on 443. So I think it's going to, okay, so this exploit just keeps on crashing. And this is most likely because we already did a buffer overflow. So what we can do is we can go back to the first shell, or I can reset the machine and try the other exploit. Maybe I can go back in the end and try it. Was the port wrong though? Oh, right. Thank you guys for notifying me. Yeah, the port was wrong. My bad. Okay, so this is the one we want to see. And would you look at that? Thank you so much for notifying that. So yeah, so even this exploit ran, which is great. So now we have 2 ways into the machine. So let's see if the system info works here. This is a good way to test. Okay, so there is some difference in the way because the exploits we ran, some things might not work. So let's just verify if we can do a who am I. Okay, so apparently there is no who am I binary, which is okay, fine. We can just transfer one onto the machine. So do we have search util? Okay, so they really dwarf this machine. They don't want us to do anything. So let's even see if our shell is stable. So let's just go to the C directory, see if we can change directories. Okay, and let's just list everything out. So the shell is stable, and I think I already found something interesting, a bank account.zip. So we can come back to this later for our post exploitation. But the first thing that I would actually like to do is both of these exploits, they were buffer overflows. And I'm not comfortable with that because in case my shell dies, I don't think running it again is a very, it might not run again, right? So we can't, it's not a dependable way. So what I like to do is quickly get a netcat binary on the machine and get a reverse shell and then continue on from there. So we don't have search util for this box, so we can just go with our trusty packet SMB server. So let's try that. So I'm just going to create a SMB directory, and this is where I'll just add the files, and I'll also start in an packet server. and impact it SMB server, call it Siddicky, the share, and in the current one. We won't have to specify the SMB2 support because we know it's running SMB version 1. So let's try to mount this. And I think I'll use the first shell because system info didn't work on our third shell, so I don't really want to take any chances, right? So let's see if there are any connections already. So they're not. So we can just mount our own share. I'll use the asterisk. This is gonna give it the directory name so that we can quickly, access it once we want to copy files. So this is just gonna make it easier for us to grab files from and reference. So let's see if this connects. Okay, great. So we can also see that if we come here, let me just also rename this SMB so that I know when to quickly come back. So we can see it authenticated and worked. So let's now we want to get who am I and we want to get netcat. So what I'm going to do is I'm going to grab both of those files. So it's in user, share, Windows, binaries. And because I want to grab two, I'm just going to use my fuzzy finder and I'm going to say who am I and netcat. Yeah, that looks good. And copy both of these files right here. So now we can copy them back on the machine. So the one place that I like to copy these files to is C Windows tasks. You can think of this as the equivalent for dev SHM for Linux. So this is a good place. I like to keep all the files. You could use temp, but in my general experience, this has never failed me. So let's just copy our binaries. Now we can just specify the Z directory. We won't have to type the whole thing again. So we want netcat and we want to copy it. We don't even have to specify the directory because we're in the directory we want to copy it to. Okay, that's good. Let's also get one. Great. So now so what we wanted to do was to get a reverse shell, right? To make things stable. So let's just do that. And I think I'll just use this window. Let me name it netcat rev. Let's do it 9001 and let's run our netcat binary. We'll be spawning a reverse shell on port 9001 and let's do a CMD. And we have a shell. So now the whole reason for doing this was, so let's say I accidentally kill this or it gets stuck or something like that. I can just quickly get back on the box by running the command again. So that's great. So now I don't have to worry about running the buffer overflow again and again. I can get back on the box really easily. So also, because this box did not have who am I on the machine, so what I'll just do is I'll just set a path and so that I can just call who am I from any directory I want. And I think the syntax for it is, and we won't have to worry about cleaning up afterwards because this is only limited to this shell. So now if I go to the C directory, let's say, and let's say I run whom. So now I can just run whom from anywhere. This is specifically important for us when we want to get our proof screenshot, right? So I think we've done lots of things. And yeah, let's get the bank account file. So I'm just gonna copy the bank account.zip and let's copy it to our to directory. But let's get a bit more organized. So I'll just create another directory called loot, and this is where I'd like to save my files too. So yeah, so let's say loot. Great. So we have the loot file. Now we kind of in the middle of post exploitation, right? So now I think it's time we get the hashes. Now, one thing to remember is that we won't be able to run Mimikatz for this because this version of decode pointer function is missing in the kernel 32 DLL. So that just means that Mimikatz won't be able to run. So we have other alternatives like Windows Credential Extractor or FG dump, but let's just go old school and do the dump pipes from registry, right? So what we can do is we can just use registry and then the same method HKLM stuff. But there's another better way about going about this. So because once we get all these files, we'll be using in-packet secrets dump to get the hashes, right? So in-packet actually has the ability to do it remotely, and all it needs is a RDB session. So this actually plays really nicely because I always recommend doing Windows post exploitation in a GUI. That really helps with the whole process because Windows you can just then not miss anything. So let's add a user, add it to the local admin, add it to the remote desktop and everything. And because this is something I do very often for all the Windows machines, I actually have a bat file created and I'll just show it to you guys. And that way it just makes the whole process much more streamlined. So let's come back to my SMB folder and let's get I call it Siddicky.bat. So I'll just locate the file. Wow, I misspelled my own name. So let's grab this file. And I also created another file to be able to not showcase proof.txt, but uh, just get the count. And there's no way of doing that in Windows. So I have a bat file for that too. So let's just also move that here. So let's see what this file does. Let me hop back onto my notes and we should see SMB. Yeah. So this Siddicky.bat basically what it does is it's going to add a new user, Siddicky with the password, Siddicky user with the password, going to add it to the administrators group, add it to the remote desktop users, and then also enable RDP sessions using this registry add key. And then finally going to run the command net users just to verify that the command ran. And the beauty of this whole thing is that you won't even have to transfer the binary to the machine. We can just call it directly from our share. Let's see if that runs. Obviously, it's going to be a bit slower, but then we won't have to worry about cleaning up afterwards. So it ran all these successfully, and we can see that the user Siddicky was added. So now what we can do is we can come back. I think we're running out of sessions to do stuff in. So let me just uh, go to my SMB and let's run the in packet secrets dump to grab the hashes. Secrets, no. And all it needs is the username, the password. We didn't export the IP variable, I think, to this one. No, we did. This is the sixth one. When we create another one, it won't be there. And now even in packet has the ability to output it to a specific file. So this again is great. So we can just use output file and we just name it, call it hashes. So while this is running, it's going to be a bit slow, but we can go check out our bank account.zip in the meanwhile. So let's see what this has. Okay, so it's password protected. Probably the password is on the zip and not the file itself. So we can just crack that. So we can just use zip2john for this, and it just needs the file, and we just call it zip.txt, and that's great. So now we can use John. And one thing annoying about John is that when you specify the word list, because it uses this argument and doesn't give us space, uh, you can't use tab completion for this. So one way to go about it is to add space, then word list, then rockq.text, but no one wants to do that and then go back here. So I'm using my Vim, so I'm just going to go back, and then so this is again very annoying for me, at least for me it is. So what I do was I just have alias called John RockView, which does the whole thing for us. So let's just specify the file. and we should be able to crack it. And the password is Alice. So again, there could be a couple of ways you could go about this. You could have tried the username again, which is one thing you can do, or you could prove. So we just cracked it. I like that. But you could have also tried your luck by using the username again. So now let's see what's in the file. Okay, I'm just going to use open, and if I have open Libre on the on my, I think it on my machine, so or LibreOffice on my machine, so it's going to default to that. However, if you don't have that installed, it will show you the contents if you just run open in the terminal. So let's see. Let's just discard it. Yep. Okay, that's great. So we can see that we got a registered username, Bob, W, and a password. So now we can add this to our post exploitation notes, and then we can be on the lookout for when we're on another machine, and maybe we see this user present on the machine, or maybe another machine that's called Bob. That this would be a good place to try these credentials if you're stuck using normal ways. So that's great. So now let's come back. And so this is still running. So while this runs, we can now grab the proof, which I'm sure you guys have been waiting for. So let's just do that. So what we want the, who am I? We want IP config all, and we want to look for proof.text. So it's in document settings, administrator desktop. Now, I really hate using double quotation marks, especially for Windows. So what I do is I just use this argument X, and it gives us a truncated, specifies the shortcut for Windows. And the basically syntax it uses is the first six letters. And if it's the individual unique file folder name, it's just going to give it one. So I'm just going to grab this, and I'm also going to grab, we want to go to the administrator, and we can desktop, and proof.txt is right here. So obviously I'm not going to display the proof.txt. You guys are welcome to go find it yourself and get it. But what I do have, I think I have dot dot. Let's see what I named the file. The word count charts are bad. Add it reverse. Wow, it's not behaving, but let's see if I have to specify the whole thing. Again, this is just me messing around. We don't really need to do this, but it's fun, right? Okay, so it's not there. That's fine. We never copied it. So what if we can just run it? So while this is running, so we can enter the file name, and that's proof.txt. Let's see if it runs. Okay, so this file contains 35 characters, including the white spaces. The only reason I ran this is just to show that obviously I am NT authority and I can interact with the file. So that's a screenshot done. So while our NTLM hashes are running, now maybe we can start a RDP session and check that one out. I think we have a bit of time. So yeah, we can now even RDP into the session. So let me just create a new here, and we can just use our desktop username, Siddicky, password, and we don't really want to mount any shares or anything. So I'm just gonna, I have to specify the IP because this is a new window and it doesn't have the variable set. So obviously RDP is a bit slow, but it does the job, right? So we're able to log in. Just loading frame by frame. Welcome to the Windows XP days. So granted, this will be a bit slow. However, pen testing is all about patience and also not clicking too much. You should have very calculated clicks. So because this is really slow, I'm just going to make sure that I don't bombard it with clicks. So, but yeah, now you can see we could have done the same post-exploitation enumeration using a GUI. And I'm sure most of us will be more comfortable with this. So especially for Windows, I really recommend once you're on the box, just get an RDP session and uh, follow and do your post exploitation in a GUI. So yeah, so you could see we could have gotten the bank account file and everything, but that's enough for this one because we already have these files. But yeah, so this is just one thing I wanted to show. And our hashes are also complete. So now if we come to our notes, you'll see in our loot folder, we have these two files, hashes.sam and hashes.secrets. So it automatically formatted everything for us and saved it right here. So you'll see we have administrator. Obviously, we added our own user, so that's fine, but we got the hashes. Now let's just crack them and see if we can get some passwords. So this again, the hashes are secrets file. It's not really going to be useful for us, but it's good to have it, right? So let's come back here and let's crack this. So we're just going to use John rock you, and we just specify hashes.sam file. And one thing to remember is if we run it by default, it's gonna, let's see what happens. So if we run it by default, it said that it detected the hash type as LM. However, it also recognized some NT hashes. So apparently the administrator hash was in LM format, but it's always great to look at these errors or these notifications or whatever you call them, and you can just also run that. So now let's try what it recommended, NT. And you can see that we got the password for Alice, which is Alice is here. Great passwords. And so that's great. Uh, if we have a little bit of time, I also wanted to showcase another way you could have uploaded the files, especially with the AD in the exam. I think it's really great to, you know, check out these tools. So we use Impacket SMB server, but we could also have used Vim exec. So I think I have, let me just locate where my Vim exec is. Hmm. Oh, it's VMI. My bad. Okay, so you can see I have several Impacket there because it never behaves. I have an Impacket for Python 2 environment, but last I tested, I think this one works. So let's just use this and see what it needs. So let's see what it requires. So it needs, we have the password, and especially we know the user, we can just use our own user. So we don't even need the hashes. I think we can just skip, run this as is and see. So I'm just going to use the user Siddicky because I gave him permissions as admin. So it's best just to use him. So this is obviously going to be a bit slow, but okay, great. So this is actually another way we could have uploaded files onto the system because this one basically, in case we don't want to go with the SMB share, the Impacket SMB share version, we could have used this. And now we can just, we can actually even run commands on this. So, and this is again, I would recommend checking it out. You can upload files, you can use, let's just use help. I think for help, we'll have to, yeah, we can just run help and you'll see that it has several options. Basically, it's going to help us put files on the target and download files. So again, great. I think we've played around enough and we have everything we need. But now finally, the most important thing is cleaning up after you're done exploiting a machine. So let's just do that. I'm just going to disconnect uh, all my shells that I have spawned. Just going to disconnect this one. And first thing, because we have a drive attached, let's unattach the drive. Wow. Okay, so the drive connection was already disconnected. And let's also clean up. So we have two files in task. So let's just do delete. And that's about it. So that's it for today's stream. And I really hope you guys had fun and it was insightful for you guys and you learned a few tricks that you can use in your time in the labs. Before I go, I'll post a link for our events page in our right side chat. So you can always check that out. And after that, silent streams every week. Definitely check it out. When I was doing my OSCP, I also used to, watch your streams. So those are a great place to catch her. And you know where to find me if you guys have any questions. I'm in the Discord chat, usually in the Pen 200 Lab channel. So, yeah. So, hope you guys have a great day, and I'll see you guys. Bye bye.